Hello everybody, welcome to the Java course. When we want to evaluate some conditions by using if or while statements, it is easy to have situations like considering more than one condition at a time. So we would sometimes use AND or NOT operators to join two or more conditions together. So let us see some examples of how we can join two or more conditions together. Let's see an example of using the AND logical operator. For Java, we have to use two such signs to represent the AND condition. Suppose I failed the math subject, but I passed the physics subject. So in this case, can I enter an engineering class? I have to check the condition like this. The whole thing is surrounded by a pair of parentheses, and math passed and physics passed is given here. It means that I have to pass both subjects in order to study engineering. So if both subjects pass, I can study engineering. So for this situation, I failed mathematics. Even though I passed physics, I can't satisfy this condition. For the AND operator, all the parts have to be true in order to make the whole thing true. If math fails, so even though physics is passed, I can't study engineering. So I will have the else part to be executed. So according to this logic, I should not be able to study engineering. Yes, that's the result. I can't study engineering because I failed mathematics course. This is the application of the AND logical operator. We are now going to another logical operator called OR. In Java, we use two vertical lines to represent the OR operator. Let us see an example. I have two primitives. One is called monthly salary being initialized as 7,000, and the other primitive is savings, which is initialized to be 60,000. If my monthly salary is larger than or equal to 8,000, or the savings is larger than or equal to 50,000, I can do something like this. The bank wants to upgrade your account to some kind of a premier account, so that in this situation, are you able to upgrade your bank account to a higher level? Let us see the result. We can upgrade the account. Why? because I already satisfied at least one of the conditions listed in the parentheses. Even though my salary is less than the requirement, I can still upgrade my bank account because my savings is already larger than the requirement. I have $60,000 in my savings account, and the upgrading requirement is that a savings account has at least $50,000. So even though the first condition fails, when I use the OR condition, I can still print out this statement because the second part of the OR statement is satisfied. Okay, we can see the third case called NOT. The NOT operator is indicated by an exclamation mark. So how can we use it? We can make use of an example to illustrate the application of the NOT operator. Suppose I have a Boolean operator called isHappy, and now it is initialized as false. It means that I'm not happy. If not isHappy, I will do the printing of this statement. So for now, isHappy is false. So not false here means true. If the thing inside the parentheses is true, I will do the thing followed by the curly braces. So for this situation, I'm able to print out this statement. Okay, if this one is happy instead of if isHappy is true instead of false, I will get this printing result instead of the previous one. So let us try to run it and see the result. When the variable isHappy is false, I will simply do this one because not false means true. For this part, I will execute this command. If I turn it to true, what do I get? I will get I'm so happy. Why is it the case? When isHappy is true, not true means false. So this part is not executed. Instead, I will go to execute the else part. So I will print out the statement saying that I'm so happy. So one thing to remember is that when we use the NOT operator, the variable following the exclamation mark must be a Boolean primitive. Otherwise, you can't use the NOT operator. Let us see some more complicated examples by combining the use of AND or NOT operators in one combined condition. I've $1,000. I don't have a laptop, so the Boolean variable called laptop_present is false. So I want to see whether I'm able to buy a new laptop according to the money I have for now. if my money is less than $2,000 or my laptop is already present, I don't buy a new laptop. Of course, if this whole condition fails, I will buy the computer. So in this case, will I get a new laptop? I don't get a new laptop because my money is not sufficient to buy a new laptop. I just have quite a few amount of dollars instead of the required amount, which is $2,000. So when I have not enough money, I can't buy a new laptop. When the second condition is true, so I will have true and true situations for both conditions. So for both conditions to be true, of course, I don't need to buy a laptop. That means I don't have enough money, and at the same time, I already have a laptop, so I don't need to buy a new one. Here, not false means true. So this part is also true. I mean, the second condition is also true. So altogether, the joint condition is true. When we use OR operator, if any one of the conditions is true, the whole result will become true. So when we are joining more than one logical operators together, we have to realize the precedence of the operators. Okay, the logic is like this. Not operator comes first, and operator comes next, and OR operator comes later. Let us see an example that illustrates this operator precedence. Suppose my laptop is already too old. I'm considering whether I want to buy a new one. Of course, I have to consider my money first. In order to consider the money, I have to set up the money variable first. Suppose I also have $1,000 only in my account. If this whole condition is satisfied, I can buy a computer. Else, I don't buy it. Okay, when I have enough money and at the same time my laptop is not present, or my laptop is too old. So when I don't have a laptop and the money is large enough for me to buy a laptop, I can buy. Or at the same time, if I have enough money and at the same time my laptop is too old, I can also buy a laptop. If the whole condition fails, I don't buy a laptop. So let me check the condition. Oh, I forgot that a semicolon at the end. So let me run it. Well, I don't buy a laptop. Why? Let us see the situation. I don't have enough money, so I can't buy the laptop, even though this part is satisfied. Why this part is satisfied? I don't have a laptop, or my laptop is too old. So both parts are true in this situation. Laptop too old is true, and not laptop present is also true. So the whole thing is true. False and true here, I will still get false, because in order to make the AND statement satisfied, all the components joined by the AND operators have to be true. So in this case, false and true means false, so I will get the else part instead of the if part. After discussing the operator precedence, I have to say some more important things about logical operators. We have a short-circuiting property of logical operators. So if we are already sufficient to determine the final result of the whole expression, I don't do the remaining part of the whole expression. Something like this. We can see an example to illustrate this property. Suppose I have 9 people. And at the same time, I have 25 oranges. If I want to see how many oranges a person can get, I can do something like this. I want to check whether each person can get more than one orange on average. So let us see the result. According to the logic, we should be able to print this statement. Yes, the reason is that this part is satisfied, and at the same time, this part is also satisfied. 25 divided by 9, according to the integer division, we will get 2. 2 is larger than 1, so this part is true. The purpose of having this part is that we have to check whether the divisor here is 0. If the divisor is 0, this part will result in an error, which is not allowed. We have to make sure that this division is able to be calculated. Otherwise, it is insensible to find out the orange per person. So let us try num people become 0. I won't get the printout because this part is not able to be executed when this condition is satisfied. So if this part is 0, I don't even come to the second part of the whole expression. So that's the meaning of short-circuiting. This is really helpful because we can avoid this division by 0 error on the second portion of the whole expression. If I don't have this part, what will happen? Let us see. I still keep number of oranges to be 25 and number of people to be 0. Save it and run it. Okay, you will see an exception arising from the arithmetic expression because I have the division by 0 in this case. Num people is 0, so 25 divided by 0 would result in this exception, which is not our desired result of the program. So when we are able to handle this situation first by having the short-circuiting property, it is more sensible to have the result of printing no strings, so that I don't have the exception shown here. So after introducing so many properties of logical operators in this video, I hope you are able to utilize them, and you are also able to utilize the short-circuiting property to prevent the occurrences of some exceptions. For example, this division by 0 exception shown in this video. This is the end of the video. If you have any questions about my video, feel free to leave your comments on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.